Hello, people of the internet. My name is William, and sorry for the lateness in videos. Things have been happening, and I haven't quite been on top of making videos and posting them online. I apologize for that. Back to the subject of math. So last time we talked about what's called a linear equation, but that only had one variable, x. Um, Today, we're going to talk about why it is called linear. There's nothing line-like about something like this until you look at it a bit closer. And we're going to explore a very simple linear equation. Y equals 2x plus 1. So that means for any pile of things x, y is 2 of them plus 1. X and y. Simple enough. So the thing to realize about math is that absolutely every single part of it is connected to every single other part. And this can be hard to realize or understand at times, but some basic thought experiments can help you lead from one area to another. For instance, we're going to start with algebra, which we've been doing. We did in the last episode, and we're going to start doing some graphing. So this is a number line. I'm pretty sure all of you are pretty familiar with it. And we're going to call this number line the x line, or the x-axis, to be very formal. We're just going to label it with x. Now, what we can do is we can put another line like this, perpendicular, straight through the other one. And then we're going to mark it off at the same intervals. And this is 1, 2, 3, 4, 5, 6. Okay. And for no particular reason, we're going to call that one the y line. Now, we have this equation up here. Y is 2x plus 1. And we know how to get different values for y when we put in x. We just double it and add 1. Let's see what happens when we plot those. So let's say that x is 0. Well, then y will be twice that plus 1. So 2 times 0 is still 0. And then add 1, and get a point right there. 2 times 1, if x is 1, then 2 times 1 plus 1 would give us 3. So we bring that up here, bring that over. When you actually want to draw it, you don't want to put the little dots in there. Those are just for like memorization purposes of what you're supposed to do. So I'm going to erase those back across. And if, say, x was -1, then doubling it would be taking it -1 back another step to -2. So we do this step twice. That's what doubling is. Much like when we did 1, we did this step twice. So by the doubling, we're doing whatever we did to get from 0 to there. We did it twice, and then we added 1. For 1, that happened to be the same step 3 times. But for like 2, doubling would lead you to 4. Then the next step would be 5. So actually we can plot to 5 right here-ish. And doubling -1 takes you this step, puts you there, and then add 1 is 1 more to the right. So we end up back at -1. So 2 times -1 is -2, plus 1 is -1 again. So -1 is x, That means -1 is y. And we've got 4 nice points here, but the thing is, between every 0 and 1, for like x, we could choose any number. We could choose 1/2. We could choose the fiddly bit that comes after the 3 point in pi. So pi minus 3 would be the 0.1415 dot dot dot. We could choose anything to be here. And if we tried to plot them each as a point individually, we would be here literally forever, because we'd never be able to stop. There are too many points for us to just dot every single one. But we can draw a line through the points and see where that leads us. Now, this is not a straight line, nor does it go through all the points, because I am not a master artist. But, you know, we can see a general trend here. It looks like all of them go on the same line. And we can see why that would be, you know, true. Between every one of the 1 points, when we started at 0, we got 1. We went to 1, we got 3. And there was a gap of 2 there. You know, from there to there. The gap of 2, and this one is a gap of 1. So every 1 we went over, we went up 2. We did the same for 2. And we could do the same for 3, except for the fact that I haven't drawn in 7. But you get the idea. For every 1 we go along here, we go up 2. So that's interesting. And we also know that down at the bottom, down here, right where x is 0, y has a very specific value. That is 1. So we have a 2, a 1, and a 1. And we can basically describe any line with just that much information. Where it crosses here, and how much it goes over for every time it goes up. Which is, you know, that's pretty good information. That's pretty neat. And in fact, we can use this to then make a formula for this. You'll often see that the general form of this is y equals mx plus b. And that is a lot of letters for something that is supposedly math. But here's what it means. This is the b. The b is just whatever dot we cross here. So what is the m then? The m is every up that we go over. So since we go up 2 for every over 1, we put the up 2 over the over 1, and we get m, which in this case is 2. So we can see how they relate to each other visually. B is where this part intersects. M is how high up we go every time we go over 1. And this is really a key part of understanding the connection between the algebra and the geometry of this whole thing. Because we're trying to plot it, we're trying to put it on a piece of paper in a way that we can see, instead of just the algebra, which is what we think when we think of this problem. And it's really, really interesting the way that algebra and geometry interact, and we'll see that a lot more as we get on into a bit more complex stuff. But for right now, this is what I want you to take away. Every line has an equation, and every equation can make a line, as long as you plot x and y. And by the way, it doesn't have to be x and y. For instance, let's say that you're going at a constant speed. Let's say this is 20 miles per hour. or 20 kilometers per hour. You know, we could say, let's say that you start 10 kilometers away from some point. No, meters is always written lowercase. Let's say that you start 10 kilometers away from some point, and you keep driving at 20 kilometers per hour away from it. That's not a very fast speed, but you know, maybe it's like a experimental raceway or something. So for every hour, you are moving 20 kilometers away. So each of these is an hour. At 0 hours, you are 10 kilometers away from it. 1 hour, you are 30 kilometers. 2 hours, you are 50 kilometers, and so on and so forth. Now, you could think, well, if I've always been driving, then at some point back here, I was at the place. And that's true. We would call that setting it equal to 0. And more generally, we call this solving the equation, because there is an equation for this line. And if we set it equal to 0, then sometimes we can solve for it. In this case, this would be about 30 minutes before, because it's half an hour ago. So we can plug this in, 20 times half an hour ago, that's why the negative is there, plus 10 equals negative 10. Negative 1/2 of 20 is negative 10, plus 10 equals 0. So half an hour ago, if you started with this kind of setup, you would have been at the place. This interplay between the line and the equation is really some of the most interesting parts of math, in my opinion. And I say that because every single part of math is an interesting part of math. But this one is a really good beginner step in learning how the algebra of a situation and the geometric, or what we can see part of it, interplays and interacts. I hope you have enjoyed and learned something. My name is Ben Williams. Some people call me the Math Hatter, and I will see you next time. Bye.